So today we're going to talk about solving equations. It's going to be like super review, kind of like from 7th grade and 8th grade. And the reason that I'm starting with this is we have the summer cobwebs, and that's okay. I just want to get into it a little bit slowly before we get into like a little bit harder Algebra 1 stuff, okay? Before we start our actual little booklet, at the bottom of the page, we have a little bit of white space possibly in your notebook, like some notebook paper part. So I'll show you underneath. I have 3 vocabulary words we're going to write down today. The first one is the word variable. So remember when we write in our journal, you can write in anything you want. So if you want to change colors, if you want pen, if you want whatever, it's all up to you. So just remember that. Okay, so a variable is a fancy math word that just means the unknown. And most of the time, it's going to be the x. So a majority of the time, the variable is going to be the letter x. But a variable can be any letter that we want to. It just typically is an x. It could be y, it could be z, it could be a, anything, any letter. That's a variable. The next word is constant. That's fine, go for it. Constant is what I'm going to call the lonely number, and I'll explain that a little bit better when we start. It's just a number that's all by itself. It's not attached to an x or like stuck to an x. Constant. And then last one we're going to do is called a coefficient. It is a number, and I'm cheating and I'm using like the actual number sign because, you know, that way our hand doesn't break off. A number placed directly before the variable. Those are kind of our vocabulary words. Those should all be kind of review words for you from 8th grade, but I know it's been a bit. So let's take our little booklet and let's go to the one-step section. Okay, so our first little section, I'm going to go back just real quick. Just make sure you have time. One-step equations literally means it only takes one step to solve them. So we're going to just start with those to get our review going. Okay, so we're starting here with m plus 12 equals 10. So when I teach this in lower grades, the first thing that I have my students do is draw a line down the equal sign. So what you need to realize is an equation is like a fancy balance scale. So that equal sign is like the break between the two sides of the scale. So we have to keep them equal because that equal sign says this has to be equal to this. So what that means is if I'm going to add something to this side, what do I have to do to the other side? I have to add the same thing over there to make them equal. And so that's kind of what we're doing when we solve equations. Okay? So what we're going to do first is let's talk about those vocabulary words real fast. So our m here is our variable. So the letter is the variable. And you don't have to, whatever, we're just talking through it. This plus 12 is a constant. Okay? I call it its lonely number because it doesn't have that variable stuck with it. And a 10 over here is also a constant for right now. We do actually have a coefficient on this one. So you're like, but wait, I don't see a number in front of m. But basically, anytime there's not a number there, it's a 1. And it's like a ghost, okay? There's a 1 hanging out right there. You don't see it, but it's there. Okay, so the coefficient in this example is a 1. So when we start solving our equation, the first thing that we're going to do is we identified this is the variable. You guys did that well, and I think I circled it or whatever, right? My goal is to get the variable or the letter on one side and all the numbers to the other side. But in order to move across that line, we have to do the opposite operation. So you guys already kind of were shouting out, like this plus 12 is what's happening right now. So to move to the other side, we need to subtract 12. But if I subtract 12 from one side, I have to keep it balanced, so I have to subtract 12 from the other side because it's got to be fair. All the time it has to be fair. So then I haven't done anything with that m yet, so I like to draw a line and drop it down. So the m's still on this side. When I have a plus 12 and a minus 12, those cancel each other out, and I X through those. And the reason I do is it's just satisfying to me that those canceled out. The X makes me feel good, like, you done, you moved, okay? And then I have to do a little math at this point, 10 minus 12. And so I know a lot of you, like, that's quick for you, but I just want to say as a disclaimer, you can type that in the calculator and, like, I'm not going to judge you for that. I would rather you type it in the calculator and make sure you feel good about your answer than you sit there and be like, okay. So 10 minus 12 is negative 2. So that took us one step and we got our answer. Now here's what I love about equations. P.S. I love algebra more than almost anything, and these to me are like puzzles. So like on our phones and stuff, we can like buy games and do puzzles and stuff. My mom, every time I walk into her house, she's doing some like word game, like she's just like addicted to it, okay? For me, equations are like my favorite kind of puzzle. So just think of it like that. We just solved a puzzle. Now, what's awesome about them is we get to check our puzzle and see if it's right. But listen to me. When you do your homework, I'm not going to count off if you don't show that you checked. And that's probably different than most math teachers. But here's why. I'm about to show you how we can use our calculator to check. So if we can use our calculator to check, I don't really know that you have to like actually write it out. Okay? But if you want to, that's great. You should never get an equation wrong because you can always check and see if it's right. And here's how you do that. We're going to take whatever we got for m. So in this case, we got negative 2. We're going to take what m equals and we're going to substitute it back into the original equation for m. So instead of m being right there, we're going to put negative 2. Then we're going to write the entire rest of the original equation. Negative 2 plus 12 equals 10. So what we could do in our calculator is type that straight in. So we would do, I don't know where my calculator went. I'll redo it. If you typed in negative 2 plus 12, you would get 10. So because it does equal 10, then we know for sure we got it correct. Okay? There it is, now that I've done it already. Negative 2 plus 12 equals 10. So as long as it equals what we said it equals, then we know we got it right. Okay? Now we get to the next one that I did on purpose because it kind of scares you already. Because it kind of looks like a fraction, and we're all kind of scared of fractions. Let's just be real, okay? So instead of being scared of fractions, which you shouldn't be, because like pie, that's a like eating like that kind of pie, that's fractions. Love that. Pizza, that's a fraction. I love that, okay? So don't be scared of fractions. But this year we're going to be even less scared of fractions because we are going to think of it like division instead of a fraction. So first step, draw your line down the equal sign. And instead of thinking of this as a over 9, like a fraction, we're going to think of this like a divided by 9. So we're like, oh my gosh, I need the a, but I need to get the 9 to the other side. So What's the opposite of division? Multiplication. So am I going to write multiplication like with the little x side like x? No. If I wrote it like times 9, that would freak me out because then I have an x and an a and I'm like, right? So I'm going to write multiply by 9 by writing it in parentheses. So here's what's magical about multiplying by 9. If you are multiplying and you have fractions next to each other, if there's the same number across diagonally, you get to cancel those out. Now what happened is we're left with a. But we multiplied by 9 on this side, so we made it heavy. So what do we got to do on this side? Multiply by 9. So negative 4 times 9 is negative 36. Also, random disclaimer, do you see how my A looks really yuck and funky? If that happens to you, just make it a capital A and it won't look so much like a 9. Okay? So yay, we have our answer. But like I said, we could check that pretty quickly by plugging that back into A. So we could, on our calculator, type in negative 36 divided by 9, except for I put a 7 instead of a 9, divided by 9. So I did it into the original equation, and when I click enter, guess what I want it to equal? Negative 4. Does it equal negative 4? Yes. So we checked it. We know we're right. We're good to go. So that's one step, just kind of getting you back into the rhythm of it. Next I want to do with fractions, and if you glued it in wrong, that's fine. Just go to the tab that says with fractions. I made an entire tab with fractions because I know we get scared of fractions. So we're going to solve it same way. We're going to first draw a line down that equal sign. And here's what's up with this one. It has 2/3 stuck to the x. That 2/3 is called a coefficient. So the coefficient of this would be 2/3. The constant would be 10. Okay? And I'm going to use kind of a weird deal to help you remember this. So the 2/3 and the x are like stuck together. They're multiplying. Like two people. Yeah? That's against the rules, okay? We don't like that. So we have to divide those two things apart because that's gross, all right? So to get them apart, we divide them. So you're like, oh, but I got to divide by a fraction. So here's how we do that in algebra. We multiply by the reciprocal. Reciprocal is a fancy word that just means flip the fraction upside down. So do you see how we're multiplying by, it's the same fraction, it's just flipped, and that's called reciprocal. And what I do to one side, I have to do to the other side. So I have to multiply it by 3/2. And here's why we do that and why it's magic. Remember how I said if you got a fraction next to a fraction, we look diagonally? And so if they're the same number, we can cancel those out. So the 2's get to get canceled. And then we look diagonally and we see we have a 3 and a 3. And those get canceled out. So what are we left with on the left side? X. Then you're like, oh, we got to do 10 times a fraction. And that's where we love our calculator. So let's go in our calculator. And we're going to type 10 times open parentheses. What was our fraction? 3/2. So we do 3 divided by 2, except for I'm typing everything wrong today. Close parentheses. So you can type in fractions by just putting those in parentheses and then click enter. And we get 15. Okay. Very good. Now I could check that by going back in my calculator and typing 2/3 times 15. And what do I want that to equal? 10. So I would do 2/3 times 15 and it equals 10, so I know I got it right. Pretty cool? All right, the reason I'm doing this one is it freaks you out because it's not only a fraction, but it's a negative fraction. Okay, so what we're going to do is that same idea. What's the coefficient is negative 6/5. And the negative 6/5 and the k are stuck together, so they're multiplying. Okay, and that's gross. So we have to divide them apart. But the way we divide with a fraction, we multiply by the reciprocal. Reciprocal is just a fancy word that means flip that fraction upside down. So it would be 5/6. But we have to have it as a negative 5/6. So what we do to one side, we have to do to the other. And now remember, when you've got those fractions and they're multiplying, we look diagonal. We have a 5 and a 5 we can cancel out. We have a 6 and a 6 we can cancel out. But then you're like, I've got a negative sign and a negative sign, but what's a negative times a negative? Is a positive. So I end up with just positive k, which is good because I want the letter by itself. Now in my calculator, we're going to type in 12 times negative 5/6. So we type 12 times, open parentheses. The negative sign is down below the 3. You have to use the negative sign in this case and not the minus, or it's going to like mess it up. So negative 5 divided by 6, close parentheses, enter, and we get negative 10. So we could type that back in our calculator and do negative 6/5 times 10, or times negative 10, and it should give us 12. Thank you. I try to make it easy. That's the whole point, is to make it more comfortable.
Can we put reciprocal in our...
Absolutely. That's a word that we will learn more like directly a little bit later, but reciprocal, I just thought I'd throw it out there for you. That's a super fancy word. So when you go home today and your peeps ask you, what'd you learn at school today that's new, you'll say, I learned the word reciprocal, and it means the fraction flipped upside down. Okay. Last one we're doing is two-step equations. Two-step equations just means we're not going to be able to get our answer the first step we do, so we're going to have to do it all again like a second step. So we're going to start with that same idea, draw the line down the equal sign. What I normally do when you see something that's a little bit bigger like this one is I box in the X. And I think of it kind of like at a dance or a party, okay? I've got this negative 4 and this X like hanging out together. And then I've got this lonely number plus 9 over here, right? Like, do you think that the single plus 9 wants to hang out with the X over here? No. Like, the 9 wants to get away because, like, they're dating and the 9's all by itself. So it kind of wants to go with the other single, people. So think of it like that. So before I mess with the negative 4 and the X, like, stuck together, like their little relationship situation, I need to move the lonely number 9 away from them. Like, get them with the other single peeps. So I'm going to move the 9 first. So I always have to move the constant first. So I do that by subtracting. So whatever sign is there, I have to do the opposite. So it was a plus 9, so I have to minus 9. What I do to one side, I have to do to the other side, or else it's not fair. So then I have 13 minus 9 is 4. I bring down the negative 4x because we haven't dealt with that yet. And then because it makes me really happy, I cross out the plus 9 and the minus 9 because those cancel out, and it's just satisfying to cancel those out. Now we have to deal with the fact that there's a negative 4 stuck with the x. So here's what you got to remember. Don't worry about the fact that the 4 is negative. Like, maybe it's just like a relationship and one of the people is a negative person, okay? Like, it doesn't matter that it's a negative person. It matters that they're stuck together. And we don't want them to be multiplying because that's gross. We need them to be divided apart. So what operation am I going to do to get the negative 4 to the other side? I'm going to divide by negative 4. Okay? So it just means one of the people in the relationship was negative, but I just divide that negative person away. And I'll leave the x by themselves. But what I do to one side, I have to do to the other side. So I divide it by negative 4. So now I'm left with negative 1 on this side equals, and what happens to the negative 4 divided by negative 4? Cancels out. So I'm left with x. So x in this case equals negative 1. Last example we'll do, and the reason we're doing this one is it's got that fractiony look again. First step, I like to draw a line down the equal sign. Now I box in where the x is. Do I have a lonely number I need to get to the other side? Yes. I have this negative 7 right here. I need to move him to the other side with the other lonelies. So it's a minus 7, so I need to plus 7. I want to change colors. But what I do to one side, I have to do to the other side. So now I'm left with x over 2. I haven't dealt with that yet. These cancel out, and then 9 plus 7 is 16. Now this looks like a fraction, and that's scary, but it's really not a fraction. This line means divide. The opposite of divide is multiply. So we're going to multiply by 2 on both sides. And because this kind of is like a fraction, and these numbers are diagonal, the 2's cancel out, and I'm left with x equals 32. Okay, so that's it for this one.